brother, there's too many of you cry. Brother, far too many of you die. We got to find our way, bring back understanding here today. Oh.
6.0s have a bad reputation. My teardown wasn't due to a head gasket failure, but I have to choose what brand of gaskets to use on this rebuild. So I'm deviating from my typical format for this series, mixing fact and observation with a point of view, right or wrong. 95% of these gasket failures are right down the center of the head, which should be telling us where to look. This is an interesting caught in the act. The rear two centers have blown out. The front is in process. As said, most failures are down the center of the head. Bulletproof Diesel made a comparison of head gaskets on the Powerstoke.org forum. And it's a good comparison. I could use just their data, but that's not me. And you never know when a company may change things in their product line. Bulletproof Diesel concluded the FelPro Gasket had advantages. While they compared several brands, my concentration is on the OE and FelPro gaskets. FelPro was a sister division of the company I worked for. In gasket terms, the fire ring is the ring added to the gasket layers, concentrating the clamping load right at the edge of the cylinder bore. The fire ring term also describes something completely different, a separate ring that fits into machine grooves in both the head and the block. I don't care for the way the gasket fire ring was presented in the Bulletproof Diesel thread. When the ring is formed, it's folded over. There can be some spring back to the steel, so measuring a new gasket may not indicate its true thickness when it's compressed. As presented, I don't consider the ring height as a doubling of the layer. The parent layer is present throughout the gasket assembly. So you get to watch a little of my measuring process. The mic I'm using goes to 5 decimal points. It also has a ball and flat anvil. Usually when you measure sheet metal, it should be a ball to discount any waviness in the metal. And for precision at this level, you use the clutch for constant torque, with a slow speed engagement to not slam the ball into what you are measuring. That could distort the reading. I'm showing measuring what I consider the critical layer, the thinnest of the 5, which is also the parent layer of the fire ring. I'll run this video in double time. The high and low measurements are kicked out, and I average all the remaining readings. The measurements can be different due to a person's technique, the tool, or parts being measured, which is why it's best to redo the 2 that I'm sampling. When the data is presented in the bottom summary as 3 digits, we are the same. Expanding to 4 digits shows minute differences. What FelPro has viewed as a better gasket is to reduce the thickness of the number 2 layer, the thickest one, by 0.02 of an inch, and increase the thickness of the 4th layer that forms the fire ring by that 0.02 of an inch. You see that in the Bulletproof Diesel data as well. For the fire ring, I'm using the thickness of the layer. Again, the fold over will be compressed under clamping load. The result is the OE fire ring is 0.07 of an inch and the FelPro is 0.09 of an inch. FelPro supplies a gasket with a thicker fire ring, making the head height at 0.02 of an inch higher than the OE. That will give 0.02 of an inch more clearance for the valves to the pistons. That's important with a higher lift cam. Notice like the OE gasket, layers 1, 3, and 5, the 3 with sealant on both sides are even in thickness, relative to any measurement errors. I touched base with a FelPro employee through a back channel when I was thinking of using the FelPro to confirm what I was seeing. I'll start by inspecting one of my used OE gaskets that is still assembled and lightly cleaned. The driver's side facing the head did have carbon staining in the web area, but not due to a blown condition. Most likely due to the rough surface of poor machining on the block side that allowed some seepage at cold startup. Flipping it over to the back side, there is more carbon staining, what tells you combustion gas was leaking. Cylinder 8 was the roughest area of the block deck. Remember, the gasket is flipped, 8 is to the left. You could see that by the stripes in the sealant, which compressed into the milling grooves. There is no evidence of the gasket being compromised. The passenger side block deck was roughest at cylinders 1 and 7, and it's where carbon was deposited again. As with the other side, carbon deposits, but no gasket blowout. The same condition exists with the block side of the gasket. Now I've removed the rivet and scrubbed the carbon from the front and back surfaces of the used OE gaskets. This is the top, head-facing surface, the first layer. Some sealing material was lost during the scrub down with a brush, but nothing remarkable about the stainless layer. The opposite inside surface of the first layer has a lighter blue sealant. An interesting thing was none of the inside areas between the layers had any carbon. I just needed to lightly wipe these down with acetone. There was no need to scrub these clean. The surfaces are very smooth. Layer 2 is the thickest. No sealant on either side. This layer may have had a raised dimple, but it's hard to observe after the compression of being installed. Again, it's really hard to tell if there was a fold or folds. There's a slight bump out in the narrow bridge section. Now we get to the fourth layer, the layer that creates the fire ring. It's 7 thousandths thick. That's not the fire ring. You can start to see some distortion from the fire ring being formed, and some corrosion or erosion on this side. I measured the width of the fire rings. Layer 5 is the same thickness in the top and middle layers, all three with sealant. Now the block side of layer 5, where the carbon had to be scrubbed off. This is the new FelPro gasket for my 20mm heads, showing the head facing side. As told earlier, FelPro has a thicker fire ring. One thing to notice about the FelPro gasket is they have bump outs at several valve locations. Also, like the OE gasket, they have sealant only on layers 1, 3, and 5. The back side appears the same as the head-facing side. As you get to the second layer, you can see a stamped area. It includes what looks like an accordion fold. The OE gasket may be similar, but my original gasket was too compressed to tell. The middle layer. The special fourth layer. A thicker layer than OE, making a thicker fire ring by 0.02 of an inch. As well as wider. The fifth final layer is like the layers 1 and 3, having the same appearance on both sides. All of the OE and FelPro gasket layers are very smooth, with an RA between 6 and 8. And they seal very well, as shown by the lack of carbon between the used OE gasket layers. People worry about the deck and heads being too smooth, but these are MLS gaskets, not composite. They don't require a bite. The technical articles and FelPro itself stated to go smooth, which I showed in the lapping videos. Why did FelPro reduce the thickest layer's dimension, number 2, and added thickness to the fourth layer that forms the fire ring? The folded region now becomes a thicker body, which is more structurally sound. If you're into house framing, it's like two sister joists, only you've gone taller and wider. The taller you go, the less deflection you will have. To the combustion gas front, these are taller. So what FelPro has done is build a more robust ring, more resistant to movement, and supported with a thicker web between the two fire rings across the bridging of the paired cylinders. The thicker web will also be more resistant to side-loaded distortion. Due to the fire ring height, the 5 layers do not see a compressive load except where the sealant is placed. I measured and calculated all the relevant areas of the block deck, head deck, fire rings, and sealant areas. And I can use that data to look at the compressive load. ARP states the clamping force of their studs, so I was able to calculate off that. I also looked at the peak combustion pressure values, but that discussion is for another video. So why is being more resistant to lateral movement significant, especially when you have this high of a clamping load? Recently, Ford had an issue with Focus RS engines' head gaskets, and there's a good research paper into the problem. In the paper, the engineers mention the 3 typical issues causing head gasket failure. Up for discussion is which of these 3 is the primary reason for us, although it might not only be one reason. During my career, we could find issues where A would not cause a problem, B would not cause a problem, but A and B combined would cause a synergistic failure. The paper has some relevant images. It shows some clamping pressure variation, the movement, and fretting of the sealant, which leads to a blowout. Fretting will shed the sealant off the steel. It turned out the fault for this was either the gasket supplier shipped or the assembly plant used Mustang head gaskets on the Focus motor, which are very similar designs. Something else that FelPro seems to have is this accordion fold with a crease in its thickest layer. Unfortunately, I could not tell if the OE did this too. This layer's bulged area may distort the 3rd layer, which is thinner, enough to help support the fire ring from moving. The other things I noted earlier were the more pronounced deviation away from some of the valves. I didn't think this was significant with something I saw when I was working on the heads, only after seeing this trait in the gasket. These gaskets register tightly to the dowels. There is a good margin from the intake valve bowl where the gasket layer edge is placed. That's not true with the exhaust valves, and it would not take much variation in the heads or the gaskets to have the gasket edge protrude into that hot exhaust flow, possibly overheating the sealant. Then I realized the bump out is not located at the center's exhaust valve. It's located where the intake valve is, so my deduction about the bump out is wrong. The debunked design concept, however, made me take a closer look at some of the failed gasket images and my own used gaskets. I placed the new FelPro gasket on the block and highlighted the gasket's clearing of the cylinder bore. These cylinders are a stock bore, not bored oversize. The FelPro gaskets are set back for an oversized bore. I could see the red line all the way around the cylinder bores. If you are starting to think about maybe a 6.4 gasket, the water flow control orifices are very different, which is interesting by itself. Certainly there is more spacing for a larger cylinder bore. While the 2 motors share the same bolting patterns and most coolant passages in the block and head, when they designed the gasket to control the coolant flow, they opted to change it. There is a major increase in coolant flow from the block to the center cylinder's exhaust ports, and to compensate, a reduction in the coolant flow at the back of the block into the cylinder head. Looking from the perspective of the driver's block deck, the center exhaust valves face to the rear of the block. It's opposite on the passenger side. The rear center exhaust valves face the front of the block. I laid the driver's old gasket onto the block. You could see the OE gasket also fits back from the intake valve at 9 o'clock. It doesn't have the pronounced bump that the FelPro gasket has, but it is set back. The same is true for the other two valves that have the Fel-Pro bumps. This is not a round circle. There is no setback by the center exhaust valve, positioned at 3 o'clock. This is consistent across the gasket. But you can feel the edge of the gasket slightly protruding into the cylinder. It has clearance to the piston due to the gap taken up by the piston rings, but it is more exposed to the combustion temperatures. Let's go back to the clearest image I have of a failed gasket, the one with the progressive failure. When looking at the bridge area between cylinders 2 and 4, it looks to me like the gasket is overheated next to the exhaust valve. The blue sealant is going away. At cylinder 4 to 6 bridge, it appears as the combustion gas has breached the seal. The 6 to 8 bridge shows more of a pronounced breach, and heat staining on the exposed edge towards the exhaust valve. So this may be a cause or a secondary development. Maybe the clamping pressure in this area is reduced to the point where the heat transfer to the mass of the head and block is diminished. Then the gasket edge overheats. When you place all three close areas together, you can readily see the setback on the intake valve location, while not on the exhaust valve side. It has no setback. When I used to port and polish 289 or motorcycle heads, I would also CC the chambers, adjusting the chamber volume so they were equal. There is always some variation in the castings, but the most important thing was to not grind the head so the gasket was exposed to the combustion chamber directly. I would recommend whenever you are assembling a motor to check the gasket for this situation. There are always slight variations in production. If it's consistent with all OE gaskets, that's a concern for me. The gasket being exposed to the combustion heat directly may or may not contribute to this issue of failed gaskets. But as the saying goes, you take care of the little things. I decided to go with the FelPro gaskets. Even though the 0.002 increase between the head to deck may enhance some of our issues, which I'll explain probably in the next video. For those that have the dollars to invest in a long-term, rust-free truck, O-ring heads are showing to be a robust choice for the 6.0, especially when adding power. O-rings may not be the only reason, though. As we all probably know, predominantly, Kill Devil is the choice for new heads with Chinese castings, and the choice for reman Navistar heads. With the Ford dealer heads, many seem to be new castings in a reman box. Any automotive machinist should be able to cut a groove for an O-ring if they have the skill. And for about $2,500, any shop can buy the tool made by BHJ. They make plates for many engines. This gentleman has a video using the BHJ tooling. He says he uses 41 thousandths wire and a 39 thousandths groove, leaving 8 thousandths of an inch protrusion. Kill Devil says their specs are proprietary, but all a competitor would need to do is measure a set of purchased heads. My old company used to do that all the time with its competitors. UCF doesn't spec it out either, but again, simple tools will tell the story once bought. The 041 wire in an 039 groove has historically been used for O-rings, both with copper and stainless wire. The placement of the O-ring is dependent on the type of gasket. From my limited knowledge of O-rings, you do not want the O-ring to be positioned over the fire ring with an MLS gasket. You want it behind the ring to support it from moving. There's a little compression of the gasket's steel layers, but not much. The protrusion of the O-ring can't be so tall that the clamping of the gasket's fire ring is compromised, as I understand it. The clamping of the fire ring is paramount. The O-ring supports the fire ring. Going back to the FelPro gasket, they appear to be trying to do the same thing. The stamping has both a crushable ring to take up any head tenting, along with backing support of the fire ring. It is not anchored like an O-ring that's embedded into the head, but possibly using the MSL gasket's thickest layer to prevent moving, along with the fourth layer improvements. So for those that have a hard time investing in the cost of O-ringed heads, $400 for head rework and a set of FelPro gaskets might get you through the night as long as the heads are not cracked, and possibly safe with a stock power level or a minor boost. UCF says you can only use the OE or Mali gaskets with their O-rings. Both of those gaskets are the same design, but FelPro cannot be used when I last checked. That may be due to the width of the fire ring. Remember that the FelPro gasket has a wider fire ring. Kill Devil says you can use any gasket. If you made it this far, thanks for watching.
Brother, there's too many of you cry.